This is really the first testbed that proves that the whole setup is possible in real realization.
I recently had the opportunity to chat with 5 early career researchers about their exciting practical work in molecular communication. This was in Erlangen, Germany for the 2023 workshop on molecular communications. It was a great workshop, and one of the most exciting activities was an experimental testbed session. The researchers I spoke with were all presenting at the session, and in this series of videos I'm sharing what they had to say about their presented work, how the technologies could be used in applications, and what they'll be working on next. This video features Medina Hamidovic from Johannes Kepler University in Linz, Austria. Medina presented a testbed that uses droplets to send messages that are detected with image processing software.
My name is Medina Hamidovic and I come from Johannes Kepler University in Linz. My specialty is communication systems, and that's the institute we come from. I have a background in electrical engineering, as majority of people in molecular communications actually, with focus on communication systems. So the testbed session was actually very cool, and what we have all shown is that it's possible to have communication systems in different forms. My session was also like that, so we have shown that it's possible to have a complete communication system established using small fluids. In my case, it was shown using discrete fluids, which somehow mimics digital communication systems. So overall, the goal was to see that we can use small fluids in a micro scale range to have a communication system established. To the best of our knowledge, this is really the first testbed that proves that the whole setup is possible in real realization, so in practical realization. So we have had a transmitter, communication channel and receiver established and working, different encoding schemes possible as well, and we have really shown the transition of information through communication system. This testbed is a first realization of this droplet encoding in its true form, so really to have a complete system realized, whereas so far we were focused on rather individual blocks and proving how does the transmitter behave or channel itself, receiver, but now we have gathered it all in a portable system, even small scale system, cheap, affordable system that allows for user interaction as well. So user can enter the message he wants to send, in ideal case his name, her name, and then have this seen in droplet encoding. Yeah, so this was really cool. Yes, and also the keynote today gave sort of really nice overview on this, and then when I saw like 10 years ago these droplets came, it's not so much, but a lot has been done in research, and also we have now these systems running. I think testbed itself is interesting because it gathers so many fields together. We are engineers and we can cover, let's say, one part of it, but then you need a good programmer to build this GUI, and it's years of work that went into building this GUI in MATLAB. Then we also need a fluid dynamics person, which again was sort of us, just acquiring new skills, and then engineering skills, of course, to control the whole system, investigate different encoding schemes and build communication systems and decoding part as well, model the channel that you have, see effects. So it really gathers so many different skills, and ultimately still have this big vision of this testbed being used in some biological applications where something will be inside these droplets, for example, some biological samples, cells. And now when we finally, let's say, got it to some working state, of course there is still place for optimizing it. But once it's finally there, you see, okay, there were so many big parts involved and it went so much effort into it. And it's kind of cool to see it now running. So MolCom itself is really small, and there are no big research groups, and it's kind of hard to get students and PhDs into this field. So when we say big, I would say it's normal group for MolCom that went into this project. So there was 3 to 4 people involved and working on it. But primarily it was my PhD thesis and then master thesis of few students or external people who jump in to build and help build GUI. But we plan to work on it further, and we will have more master students, let's say, coming in to optimize it further. So it requires few people. It cannot be one person, but 3 to 4 people at least is working on it. We plan to develop it really to a state where it will be well presented to general audience, so we can use it for exhibitions. And in that state, it has to be ready to transmit any message, for example, any username successfully and every try. and to this date it's not yet there, and we plan to invest 1 or 2 more years to get it there. So right now it's for us a demo kit. Of course, we are com engineers, and for us the purpose is to have a communication established, and this it can do well, but ultimately we want this testbed to be in some biological lab. So this would be really cool to have people trap these samples inside our droplets and then use our encoding or the whole communication system to decide what is being done with these cells. So we could sell it or give it to some biological labs as a kit, as a ready portable system that they can use to really efficiently isolate some samples inside and not have some complex electronics decision making, what to do with these samples.
That's all my questions.
Thank you.
Very much for your
Thank
time.
you.
And thanks for the test bed.
Yeah.
That's all for now. Thanks for watching. You can like the video and leave feedback in the comments. I will be sharing more conversations from the 2023 workshop on molecular communications in a later video, and these will be combined in a playlist. Consider subscribing to stay up to date with releases, or if you'd like to see more research highlights and tutorials on biophysical communication engineering. See you next time.